R. Oh, it does record with Alt R. Okay, so we're gonna start with mm, differential equations, first order. Finally, we're back in it. The differential order, the things that actually give or take is what really is engineering, basically. And physics, basically. All of engineering is pretty much defined by a differential equation, one way or another. Either it is estimation, which basically means in the end of the day, there's like, in the end, like it's a high estimation. Oh, look at that. That is that. Or in another case, it would be this kind of situation. So, for example, we start with F1 equal ma, force equal ma, because excuse me. I forgot why. My brain just blanked. I was discussing why this was valid, and I just forget. Or whatever. Everything is. I mean, it's not ordinary. It's partial that's more important. Give or take, yes, it's more important to know that one. But for now we're going to ordinary. Actually, maybe it's not. Hmm, interesting. And it might not be. But a lot of times you don't need differential equations. You actually don't need it, actually. Thinking about it, you don't need it unless you're doing a weird, small, micro, or big scale. It would be estimate. Oh yeah, you're right. No, 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 I'm wrong. I'm wrong. So this is only useful for trying to figure out something tiny or research heavy stuff because you get a final equation and you just keep on using that. So I'm wrong. Even then, there's some equations that don't need that. You can just estimate it, like Q equal UA delta T. Wonder, I hope I remember that. I think I did. HVAC definitely doesn't need any. I've seen a lot. HVAC definitely doesn't need differential equations. I don't think. So far as I know it. You don't need it? I have no idea. I'm cringing right now because I have no idea. Anyway, so F equal. Let's just go. Let's just go to differential equation, man. Ordinary differential. Oh. Okay, so we're going to F equal. I'm getting sidetracked so badly. F equal ma. It's the net force. We're going to Newton, and we're doing a basic differential equation, which is gravity. And we all know this differential equation. This is the fun one, the easy one, usually. Yeah, it's easy one because you learned that in like finally done with physics. Actually, I'm not done with physics. I need to reformat it, but I'm too lazy to do that. So. A lot of time is time, but there's also spatial. Actually, there's more spatial, I think. And I know a lot more spatial than actual time. Interesting. That is interesting. I didn't know that, but I actually know more of time than and I know more of spatial ordinary differential equation used than time differential uses. Actually, no, I don't. I do know more of the time now because of the Wolski and the Stokes theorems and Stokes first problem, second problem. Yeah, never mind. I take all that back. So we go over here, we get this. We're starting with this. We're just practicing more differential equation separation, basically. And then we finally get into the hardcore shit, where we get error functions. I start off with error function very fast because I was shocked by error functions in the yeah, I forget when, but we actually did error functions before too, so it shouldn't be that difficult to understand. Anyway, we keep on going, and then finally we get to the physical part because a lot of differential ordinary equations, no fun without physics. It, you can do it without physics, and you can just get the answer, but then I realized, wait, what's the fun of that? There's no meat to it. Uh, there is meat to it. There's fun in that actually. I find it fun, but you get what I mean. Like you kind of need to wrap it with physics sometimes to make it understandable what you're doing. Uh, for some people just the math is fun, just following through it. I find both ways fun. It's just that it's just on the day. Like some days I feel like this is more fun than this. I don't know what I'm saying. Anyway, you kind of get the series of like, well, I was thinking about this question and I realized that I didn't in the original way I did it, I think. I did not have this fan over here, and I realized, it needs to be well mixed. So let me just emphasize that a lot because if it's not well mixed, it is shit. No point credit, but this differential equation is garbage. This differential equation approximate a lot. It's approximating a lot because it's a liquid, but it doesn't have any like fluid mechanic property. You're assuming you're just dumping it in and dumping it out. You're basically saying it's a dumper and inner. It's not. It doesn't have any pipe. It's just dumping in, dumping out in not even Purcell, not even anything, just dumping in from a large. You can think of this as a even bigger reservoir, and that's falling in. And for some reason, there's a tuber here that causes this to happen. You're assuming a lot. You're assuming so much. Um, but and I realized I do want to at least show a little bit of the assumption over there. Like there's a big assumption over here, big assumption over here. Uh, you need to assume so much for this to work. So I said, you know what? If that is the case, I am at least going to show some of the assumptions here. Because the amount of assumptions you need for this is insane. So at least I'll show one of them because I realized that the assumptions are almost like what? Yeah, literally what? Like so I decided to put at least one assumption there. And then another so I did that for all of them. So I did it with two different methods, separation and uh, the U method, the Pacific thing, my favorite. Um where is the EXP? Did I not do the EX? Oh, here it is. Um Now, that's the easy case. We went to a harder case where it broke, and I thought it would be simple enough until I realized, yeah, this became a pain. Oh, and why is this still here? So what was happening is I was doing, there's many ways to actually solve it. There's actually one way that gets an imaginary number. You have to kind of convert it to real. The C becomes imaginary, and you have to do some fancy shenanigans to get it into real. There's a hard way and an easy way. The easy way is this. If you do it a different way, it becomes like a pain in the ass for some reason or another. Now, this crack also assumes so much. This crack. Uh, I think needs to be a little bigger, first of all. And the crack has to be somewhat well formed in the mixture. The crack cannot form over here. The crack cannot form over here. The crack cannot form over here. The crack has to form near the outlet. And this outlet, I believe, don't like it because the outlet doing it this way makes it more actually doing it more bottom over here makes it more likely for this to happen because we're going around, round, round, round. And this blade turbine, okay, I think we need to make a bigger turbine. If this was to do, if you want to make this work, I think you have to do something like this with different cylinders so they mix well. And you're gonna have to use the convection to drill the water inwards like this kind of weird octagon to make the salt mix in well enough that this approximation is good. Well, that's my opinion. I don't think this approximation is a good thing unless you have some kind of salt bed, something. Okay, you go what I mean. This approximation needs it's assuming a lot, and I think that would make it work. Otherwise, I think you're just gonna have what I personally think is gonna happen if you don't mix it well enough and put it top over here is that you're gonna have something like salt heavy here and fresh water here. Something like this, maybe. I have no idea. This is just my headcanon because my brain is working through the thing. But I think the salt will collect over here. If you don't have the mixing thing, definitely it's gonna happen something more extreme than this or something I wouldn't expect. Maybe salt is going down, right? So it would go over here. I think this is kind of how it would be without some turbulent force making this going like this. Um, Without that, it would just stray like that, and the mixture I think would be something like a gradient. If I were to graph the density, let's say density, I think it would be something like this. It would be a slope like this. It won't be a big slope, but I think it would be a slope like that. Maybe it won't actually. Maybe it would just be a different density. I don't know. This is just my thoughts. If you don't mix it really well, anyway, you have to mix it very well. Otherwise, this thing is you can lose your hat. You can lose your idea and your. I'm just gonna stop the recording. I'm done talking. Uh, I'm basically saying that the first ordinary differential equation here is, I need to do second order, but now I'm done with this one.